problem 171 can be seen as a simple memorization pattern. The question is asking which material is most commonly used as a transducer element, that is, as a piezoelectric material. The correct answer would be option C. This can also appear as PZT in similar expressions. Since both are synonyms, you should remember this through this problem. Moving on, let's look at problem 172. This problem contains some rather complex content. You can refer to the content when solving the problem. Looking at the sentence, it says that a thyroid ultrasound examination is being performed using a linear array transducer. Compared to abdominal ultrasound, the thyroid is an organ that requires high resolution. A standard B-mode image is being obtained, and the question is asking how the pulse should be generated. High resolution means that the spatial resolution is excellent. Therefore, axial resolution needs to be maintained at a good level. If that's the case, the shorter the pulse length, the shorter the SPL, spatial pulse length will be as well, and these results are related to situations where the axial resolution improves. Although we can't know exactly how many pulses are emitted, we can say that choosing the shortest one among the options will result in better axial resolution. So the correct answer would be to select option A. Therefore, for this type of question, it's not about memorizing how many pulses are emitted, but rather about understanding what the question is asking, specifically which option to choose in order to achieve high-quality axial resolution. Since the pattern is somewhat complex and there is room for debate, you should just try solving the problem for reference. Next, let's move on and look at question number 173. If you look at the question, it asks about the purpose of using a matching layer. At the front of the probe, there is the foremost crystal, and in front of that, a matching layer is attached. These parts are in contact with the skin and serve as a bridge to ensure that the sound waves are transmitted well. The correct answer would be option D. The important point is that it improves the transmission of sound waves. It plays a role in adjusting the acoustic impedance in the part where the sound is transmitted from the element to the tissue, or additionally. If we assume the element is 100 and the skin is 20, the greater the difference in acoustic impedance between the two, the more difficult it becomes to transmit the sound. The coupling layer in between serves to maintain an intermediate value, allowing the sound waves to be transmitted more effectively. So, it adjusts the difference in acoustic impedance or serves to transmit sound waves effectively. These are the keywords associated with the coupling layer. Next, let's move on and look at question number 174. The keyword you need to pay close attention to in this question is the term non-focused. It refers to a state where focusing is not applied. Usually it can be divided into two cases, when focusing is not applied and when focusing is applied, and there is a difference in terminology between these two situations. Since the question is asking about non-focused, you need to choose the term related to this. The question is asking which area the sound beam gradually narrows. The correct answer is C. If the question had included the expression focusing is applied to this part, then D, focal distance, could be considered the correct answer. So the key point you need to remember from this question is that there is a terminology difference between when focusing is not applied and when focusing is achieved. Next, let's move on and look at question number 175. This is also a frequently appearing question pattern. You can consider this as a simple calculation problem. In this question, a disc transducer without focusing is used, which you can roughly consider as the diameter of the transducer. Here, the question is asking at which point the beam diameter becomes the narrowest. The beam converges like this, and simply put, it appears at a distance that is half the diameter here. So, in terms of position, the formula that divides by 2 is the most relevant keyword here. If you look for the correct answer right away, you should select option D. Alternatively, the question could be changed to ask, if the disc diameter is 6 centimeters, at which point does the narrowest focusing occur? If you simply divide it in half, 3 centimeters would be the width where it is the narrowest. This is a simple calculation problem and also a question that checks whether you understand the basic concept, so make sure to remember it well. Moving on, let's look at question 176. Questions 176 and 177 are patterns that ask whether you know the characteristics of the probe. These two are also patterns that are always included in the exam, so make sure to remember them well. If you look at this problem, the most important point is that they are trying to obtain an image from the intercostal view. A liver mass is suspected, but it's described as being small in size and the patient is elderly. Also, there is no mention that the patient is large or obese. The fact that they are scanning the liver through the intercostal space is the biggest clue here. Usually, since the scan is performed between the ribs, the space can be considered narrow. So, rather than using a large convex probe, it is necessary to use a smaller size. Therefore, if you see keywords indicating that a narrow area is being examined like this, you should choose option C as the correct answer. In a very similar way, when you're examining young children with a petite build, you will find that these specific keywords are also highly relevant to your search results. Next, let's move on and look at question number 177. When preparing for the physics exam, you may encounter questions that include these kinds of clinical terms. Ultimately, what is being asked is at the end, so even if you don't know the content at the beginning, it doesn't mean you can't solve the problem. So, it's most important to accurately determine what the question is really asking. First, if we interpret the overall context, it says that an endovaginal examination is scheduled. Looking at the reason, it says that bleeding has occurred after menopause. So, they are planning to measure the thickness of the endometrium. Even if you don't know the previous part, let's start by looking at the latter part. What is the main advantage? This refers to endovaginal. It's asking what the main advantage is when performing an internal scan. Compared to the typical curved linear probe, when observing the pelvis with an abdominal ultrasound, there are two methods. One is viewing through the abdomen, and the other is inserting the probe into the vagina for a direct examination. Here, the question is asking what advantages endovaginal ultrasound has compared to the other method. As a result, I want to emphasize once again that even if you don't know these terms, it doesn't mean you can't solve the problem. The correct answer is to choose option D. Because the examination is performed from a much closer position, you can observe the images in greater detail. Since a high frequency is used, it provides higher spatial resolution. You can consider these statements as the keywords most closely related to endovaginal or intracavitary scans. Now let's move on and look at question number 178. Yes, this is the most basic formula for the question. The formula related to axial resolution is option C, which is the value of SPL divided by 2. Calculation questions like this can appear on the exam. For example, if SPL is given as 4, you could be asked what the axial resolution is. You simply need to divide by 2. The question right below is also related to axial resolution. What the question is asking is which option allows the axial resolution to distinguish the smallest parts. If you think about it simply, in order to distinguish the smallest part, you need to have a correspondingly small value. It's a simple pattern where you just choose the smallest value from the options. If the axial resolution is shown as 0.15 millimeters, it means you can distinguish something that small. The important thing to remember is that the smaller this value is, the better the image quality. Next, let's move on and look at question number 180. There is an error in this question, so I won't be providing a solution for it. Here, option A is labeled as wavelength, so I'll explain a diagram related to wavelength separately. If you look at the diagram, the distance from the first peak to the second peak is called the wavelength. So, when you see a diagram like this, remember that the wavelength is the distance connecting the first peak to the second peak. Next, what you should remember is the difference in wavelength between low frequency and high frequency. If you look at low frequency, you can see that the distance to the next peak is long. In low frequency, the wavelength appears long, whereas in high frequency, you can see that the peaks are connected closely together, showing the opposite. In such cases, you can remember from the diagram that high frequency means the wavelength is short.